Hi. In the free Pascal basic tutorials, I reached the point where we can start to talk about the main purpose of an object-oriented language is the objects and the classes. So in free Pascal, there are two different types of, let's say, objects, and at first we had the object types, and later on this was extended to the classes as the language evolved. Basically, the two concepts, the object and the class types, are pretty much the same. The difference is only where how they are used, or how they can be called, or how their objects can be initiated or can be created. So at first I will start with the object types, and in a later tutorial I will also talk about the classes, and you will see that there are some small differences how you can create the classes, how you can create the objects. And the basic thing is behind them is also where they are stored in the memory, and how they are how their space in the memory is allocated. But in both cases, the main concept is basically that as the name suggests, that you have objects, and these objects can be um, multiplied, or multiple times can be used with their own instances. So with this, you don't need to recreate codes, or you don't need to deal with the individual instance information, like variables, or calling the procedures with the specific variables, if you want to create something which requires similar kind of objects. Like, for example, in games you might have uh, um, an enemy, for example, where one enemy is describing how the enemy should look like, and if you would like to have many of these enemies, you don't need to individually take care about their information, and calling the procedures, functions, checkings, like collisions for the individual elements. You can basically program it into the object, and when you are calling the object itself, then it can evaluate its own, um, let's say, status, and also update the behaviors, can call the internal procedures or functions without uh, additional information required from other side of the program. So these objects can represent really one entity, and this one entity can be um, handling their own processes themselves. This is the basic thing about the object, so that you can have many of these instances of an object. But the biggest idea behind it, that you can define a basic object, and you can extend the behavior of this object by creating some, uh, let's say, child objects, or inherited objects, actually. So, for example, so if you consider this inheritance type of thing from one object to another, you can imagine that you can define as a parent object a house, and you can define different rooms inside the house. So however, the house has walls, like also the rooms has walls, but the let's say, the room is considered to be a smaller portion of the house, and you can use inside the house different rooms, like living room, bathroom, kitchen, um, loft, or whatever. So basically with these let's say modifiers or modifications to the objects, you can create individual kind of child objects, and you can extend the behavior of the original object. So let's see how we can program an object in Free Pascal. So the basic thing is that the objects or object definition is pretty much the same like when you are defining a structure or record. So you need to start with the type statement, and then you need to define the type itself, which will be the object name. And then instead of using the record identifier, record statement or record command, you could or you need to use the object statement here. And then after that you can define individual fields like in the records you can do the same, but here you can also define procedures and functions, and also you need to define constructors and destructors. So these are the basic elements of the of an object, and the other thing is that you can also define that where these elements should be available. So here, because I'm using only a very simple program here, and I'm not using units in this program, but later on you will see that when you are using units this can be more complicated. You can define for your objects that how their procedures and even the variables or their object fields visibilities. So if you define them private, public, or protected, then the visibility of these sections or fields or procedures, functions will be different. And here I mentioned what you will see if you are using them in units. As I said, in this program, these let's say modifiers doesn't really have any effect. But if you would like to use units or you define some objects in different units, then you can control these behaviors with these modifiers. So typically, if you don't use any modifier, then all the procedures and functions will be public. So will be visible for child objects, and also visible for child objects in other units. But if you define them private, this means that it will be visible in the same code, but it will be hidden for any subclasses in other units. Which means that if I would have a subclass like I have here, the child object, but this child object would be defined in a separate unit or a separate program segment in another file, then I would not be able to see the IAM private procedure in the child unit. It could be code, of course, within the same class or same object, but not within the child object in another unit. If it is called, or if it is used with a protected modifier, then this would be visible for other subclasses or sub-objects in other units as well. So this is the parent unit and parent object, and actually what I did not mention is the constructor and destructor. So basically these objects or these procedure like things are responsible for initializing the objects when they are called. So if you have any value what you would like to initialize, then you could be able to do it with this. And with the destructor, you need to make sure that you are freeing up the memory if you were allocating anything inside the object. With the destructor, you should call this uh, memory cleaning processes inside the destructor. The naming, of course, can be different. So here I was using the init or done, but it can be create or destroy or whatever you want. The important thing is that when you initiating it or initializing the object, then you should use these calls. So let's go how we can define a child object. So basically the child object can be created using the object keyword again, but behind the object keyword you should define that which object is the parent object, so with which parent you would like to create this child. So basically this will define that you are extending the parent object with additional things, or you are modifying the behavior of the object. So here, as you can see, that I was creating again a constructor, destructor, and I adding a field as well, a second int value as an integer type, just to show that how these are, let's say, used inside the object. Then the procedures are basically the same here, except that the private function is not called. And I was also creating here an additional procedure which is not part of the parent object. So this set value procedure is intended to extend basically the parent object with an additional feature here. So then we can come to the definition of the different functions. So here I'm using the constructor for the parent. So as you can see that when you are defining the procedures or any or any constructor or destructor for the object, at the definition part of it, you need to also mention the object name itself, so or the object or object type itself. So as I define the T parent as an object and the T child as an object, all the related functions or procedures should be, let's say, naming the object itself, and then you can continue with the procedure name or function name. So here you can see that the init function is initializing the int value from the parent object. The done is basically just zeroing it out, because here I'm not doing any dynamically allocated memories, so I don't need to free up anything else in here. But what I also added here is that when you are referring to the object fields or object procedures, you can omit to use the object name itself. So within the object, the value will be used, or the fields will be used without the object name. If you want to refer to the current object, then you can use the self let's say variable to it. So this basically tells to the system that you are talking about the value for that specific instance of the object, if you might be defining many of these. And later on you will see that how these are or how the fields and variables are basically used within the within the objects. So then here the procedure call me is just calling the IAMPrivate procedure. The IAMPrivate is writing out the that it is called in the parent um, parent object, and writing out the int value. The always same is just again calling the call me procedure. And here we reach the child object already. So with the constructor init function, what you can see here is that actually the init function can be completely individual. So basically, when you are defining your child child object, then this child object can um, initiate the object itself with all those inherited fields and maybe calling some functions as well, which are basically linked to this instance. But if you just want to go to the parent init function or parent init procedure, then you can call it with the inherited statement, and then this will call the actual parent init function. But as you can see here, the parent init is initiating the int value with 1. But here, if I'm using the child init, then I basically override this value with a 2. So this is also possible. Of course, here it makes no sense to call the parent inherit function. I'm just calling it just to show that basically what is inside the parent init is also called if I'm using the inherited statement or keyword. Okay, the done is doing the same, like the parent is doing. At the call me procedure, again, I'm calling the original inherited call me. Actually, I can delete here the call me as well, because this should work without naming the actual procedure. This should call the original call me procedure if you are overwriting something. Of course, if you are not overwriting something like the child value, the inherited keyword is not doing anything actually. So you can't or you don't really need to call this function or procedure, because it will not have any effect. It will not find the parent procedure or function. So here I was creating a set value procedure just to show that if you are defining an object, then its parent object is also let's say belonging to this child object or child object instance. So actually, when you are creating the child object, you are also kind of creating the parent object instance as well. So basically, when you are using the instance object itself, then these parent object fields are also instance field of the child object itself. So it's not really an instance of the parent object, because this is kind of encapsulated inside the child object, but all the fields will keep their own values, except if you are using kind of static values, what you can also define for objects. But I'm not going into these details now, because it's it is relatively rare that you are using objects in many instances, and you want to have actually one, let's say, common value for, or common field for all your instances. So it is better to really keep the objects completely separated and using their own values. And if it is needed to have let's say global values for all the instances, then it's better to take care about calling a function or calling a procedure, which is basically changing the value for each of the instances together. It makes actually the application more clean and readable, and it's easier to debug at the end. Okay, so basically that's all, and now let's talk about how you can create your objects. So if you are talking or if you are talking about objects, there are two ways how you can create an object. So basically you can directly link to a variable like here. As you can see that if I'm defining the parent variable, I'm using the tParent object to be defined for this variable, and also the same for the child. But you can also define them as a kind of pointer. So basically, as these can be, let's say, dynamically created during the application run, and you can basically dispose these objects if you don't need them anymore. Then you can create this kind of let's say pointer types defined. So actually this p-parent will be a t-parent object pointer, and when you are defining like this, during the creation or running of the application, these objects are not created when you are compiling the application, just when you are running them. In the other case, the parent object and the parent or the child object is created right at the compile, so you will have one of each object, let's say, allocated already when you start to run the application, and this will be available during the run until you are let's say finishing or exiting the application itself. So one is a kind of static allocation of the memory, and the other are just allocated when we reach the or when we create the objects dynamically in the application. And to show also that how these objects are behaving if you have more, then you can create or an array of objects. And here the important thing is to mention that actually the object procedures and object functions will be created only once, but all the related variables or fields will be individually created for the objects, and whenever the procedures are called, these will know exactly which variable to be used in their run, let's say. So this means that this kind of definition, or this kind of creation of the object will save memory, because you will not, let's say, duplicate the procedures and functions in the memory. You will just have one object with the procedures, or one memory space with the objects, and whenever you call a procedure, the application will know where to go in the memory, and run the procedure itself inside, and will link the instance fields or instance variables to this calls, or to this runs. So you can create also an array of the pointers, and you can create these objects using or let's say linking to this array. So now let's see how we can create the different elements, so or different objects. So here I started with the dynamic creation of the object. So basically, with the new statement, and using the object itself, or the pointer type itself, or the pointer itself, which is defining that which object should be created. So the pointer type itself will define that. The function call, or this new procedure call, and also mentioning the constructor name here, will call the object's constructor method, and this method will take care about the initiating of the values for this object, and creating the object in the memory, and link it to the pointer, the p parent pointer, this created object. The next one is for the child object. So this is the same with the new statement, child object, and the init function of the child object itself. And you will see that how it's running. Then the parent. So if we are defining the object as a kind of static variable, then you can also initialize this by calling the init function. So basically, it will do the same like with the new statement, but here the object already created when the variable is created for runtime, and then you just need to call the init function. And because this will be freed up at the end of the application, here you don't need to do anything with the dynamically allocated objects. You need to dispose them. So here later on you see that the disposal is done by calling similarly like with the new statement the object itself, and using the destructor method. Then to call the procedures inside the objects, of course you can use the object variable here, and then use the function or procedure name after the dot, and then this will call the procedure. In case of a pointer, of course you need to convert the pointer to the actual, let's say, point of the memory. So here the pointer should be or the object related to this pointer should be addressed here, and then you can use the dot and the procedure name. So these two lines will basically do the same. The only difference is that how the object itself is created. Same for the child objects. Then of course freeing up the memory with the functions or with the objects. So after these, if I would try to call the the object, then this would or should not work. And the same when you are creating the array of elements. So basically here you have again the new statement calling the pointer itself, which is now in an array using the init function. And here you will see that how this individual objects behave. So if I'm using, or if I'm calling only one of the objects from the array, so the second object, and I use the set value procedure, setting the fields of the object itself to 5, and then I'm writing them out again. Then you will see that these will basically keeping their own field values inside. So where I did not change the values, we'll use the original values got in the init phase, and the after the set value, the second child second child object will have the 5 in the instance fields used. And then of course, because these are also dynamically created objects, I need to dispose them with the done function. So running the application like this, and let's go through how this look like. So let's get to the top. So again, if we go through, so you can see that at first the parent object itself is initiated, so it's called. Second time the child object is child object's init function called, but this was also calling the parent init function. And because of this, you can see that the parent init also called for the child init function, or the child init method. Then second case, the same, just the for the, let's say, the variable type initialization of the objects. And then here the call me procedures called for the parent functions, and also parent objects, and also for the child objects. So where the child objects is also calling the parent objects call itself. And as you can see here, the child object was also redefining the field inherited from the parent object. Yeah, so this is the same in both cases. And then the disposal of the objects, again similarly. So in both cases the done destructor is called. And then we reach again the init functions for the child object arrays or child object array elements. So here you can see that the parent and child init functions call 2 times, just like it's defined. And now we reach the set value. So here you can see that when the set value is called for the child or the second child object here, then it's also writing out the value. So actually the parent int value is also set to 5 here. And as you can see that when the child call me function is writing out the values itself for the second field value and for the parent int value, or not parent int value actually, because it's the child inherited int value. So you can see here that it's also set to 5. But if I'm writing out or calling the call me function for both objects, so both child objects, you can see that the first child object was still keeping the the initiated second value as parent value as 2, also int value 2, and the second value was 0. So however it was not initiated at first, it is now was 0, and for the second one, because I set it to 5, the values are keeping the 5 inside. So if you just try to imagine that you have maybe a game application where you have two balls rolling with speed, with the same speed, but you just hit one of the balls, and the speed or direction of this ball is changing because of this. Then you just change for this object these values, and the other object will keep its original speed and orientation, and then these two balls will basically move after the force is applied to one of them. Will change the direction and the speed compared to each other. So this is the idea behind the object-oriented programming, and also how you can use them. At first it might be a bit confusing, because sometimes you don't really see what is happening, but actually when you are designing an object-oriented application, you should always consider that what the object should look like, or how you should split up the different behaviors if you want to define objects and their child objects, or um, or those objects which should implement something from the parent object. So you should always consider that what is common, what is different in these objects, and then of course you can define what to be defined as a top object, and what should be defined in the child object, and with this you can create a kind of object tree, where from the same parent object you can define multiple different child objects with different behaviors. So for example, if you consider that from a seed you can have different kind of trees, and the different kind of trees have different behaviors, or even one is not a tree but a flower. Then you can define these objects, let's say, with those individual kind of behaviors and kind of values which are specific for these different objects. So that's all about the objects today. I hope you enjoyed this short tutorial, and if so, then please don't forget to subscribe. And with this, I wish you happy coding for today, and see you next time. Goodbye.